Hello there, everybody. This is Nick Losi and Emmy Jakob here. We are going to be talking about our project on virtual reality trainings.
All right, so first let's look at some of the uses for virtual reality in training. So currently it's being explored in organizations due to some of the high costs of training themselves. And a lot of those high costs, a lot of people see them in mistakes during trainings. It also helps with innovative education efforts, and we've seen it in uses for ergonomic designs. Um, so the potential for virtual reality or VR training really is to offset compliance costs and costs of training. We see a big learning curve when it comes to training, so we wanted to be able to use virtual reality to offset some of those costs, as well as it could limit on-site, it could increase on-site physical training instead of actually having to do it off-site. You can do it on-site as well as with a virtual non-spatially constricting locations. So some of the VR studies that were done, one of them addressed basically behavior compliance during hazardous scenarios. So during a dangerous environment, or if during any type of evacuation need to be done, you can recreate that through virtual reality and then do training based on strategy to combat any challenges that would occur during those times. Also, it's being used for development of educational tools. Instead of developing a physical workstation or work environment, you can recreate one virtually and basically then start to establish relationship between student connections from computer-generated environments and physical environments. Part of that is kind of what you see on the right as well, but that's also mostly kind of linked into that last study, which was ergonomic verification. So what you see on the right is a movement study of a hand in a workstation or a work environment. And so what you can see, the benefits of that to virtual reality is really in the product design phase, and as well as controlling dashboards and analysis of movements. So our proposal was basically to baseline and improve on human performance in an employee training environment through the use of virtual reality systems. So our aim is to find an average value of time, how long it takes, and costs associated with trainings within the mechanical engineering lab environments. Basically, we wanted to develop a 3D video of a training tasks, train the mechanical engineers and with a sample size to perform the job based on their designated method of training, which is their standard method, and then compare it to virtual reality. So perform that verification testing on each of the individuals to perform measure learning of tasks and quality of training. So we wanted to measure results through a performance of those tasks and looking at things like time, correctness, their confidence of the trainees, how likely they'd be to recommend it to their classmates, and then be able to develop an effective method of training based on the performance leveling scores, relationship to the cost of the time it takes to train individuals, and other things like that. So our project included having a Google Cardboard, and that cost, and then what it was, and then having a 360 camera, which we were able to use from the department. And we used Unity SDK to develop the app. So here is the experiment that we were working on. This is a heat transfer base unit. Basically, it provides cold water and a heating power to the optional experiments. Basically, you have experiments of testing with different types of materials that heat across, or as it heats water across. And what you want to do is you want to measure the heating element's performance by taking points of measurements throughout that rod, or whatever you have the contraption.
So now we're going to talk a little bit about how we developed the virtual reality training and some of the workflows and resources that we came up with through that. The Unity development environment was critical to actually stitching together the virtual reality video. We utilized a 360 camera that was loaned to us through a friend, and that was what we used to actually film the video. That was exported to an MP4, which was then sent to this website called Omnivert, which allows you to transform the MP4 video into a format called equirectangular. And that's what you use when exporting videos to the virtual reality format. So talking about our workflow, we would have the training process with the candidates. They would sign some form of release waiver form just for safety reasons, and then they would read the lab procedures. From there, there would be the difference between the standard training process versus the virtual reality training process, where they would either receive group training or the virtual reality training. And then lastly, they would take the performance leveling quiz to measure their level of learning, which we developed some tools to actually measure that, talking with mechanical engineering professors and students who had already performed the lab. And finally, there was the participant who would then actually perform the designated lab procedures. And for our study, we just measured different verification of performing the tests through taking time measurements, but visual verification could also be done. So here are our two performance leveling tests that we used. On the left, this was what we used to take time, the 6 different procedures that we measured the students performing. And then on the right was what the student would fill out on their quantitative level of confidence, comfortability, and how they actually liked the training as well. This is just a snapshot of our actual video. We had 2 lab technicians that were familiar with the lab equipment actually performed the training video, and they went over things like safety equipment, wearing protective eyewear, and then as well how to set it up, and they trained the actual student watching the video on how to perform the 6 different tasks. And then lastly, we're going to talk about some project findings and conclusions. So one thing that we notice is in making the video, the best possible thing to do is to figure out how to optimally train for when you're doing the actual recording, because whoever is going to be watching the video, you want to limit their number of questions as best as you possibly can. So to create the optimal video, the people creating the video must have the greatest familiarity with the equipment and the concepts to lead to the best developed training. I think in our case, we were just working with lab technicians who had performed the lab, but they may not have had an expert level of understanding. Additionally, I think it is best to increase your scale of testing population. That was something that we ran into as a problem because we had such a small scope using mechanical engineering lab equipment. We could only test a few individuals, and it made it hard to get participation. And then an additional finding was that VR may be better suited for an interactive training environment. For this specific test, the user is just kind of passively watching the video, but a better instance might be if they watch a specific portion of the video and then perform a measurement or test. And then Amy's going to share some implications and wrap it up.
All right, as you can see also, some of our implications we looked at was that basically these training videos in VR will probably be best suited for a supplementary style of teaching instead of actually replacing the content itself. But this should happen just about until I assume we can catch up. Once we do the conclusions and the findings that we found above that Nick was talking about, we do believe, it is our opinion that the VR approach to training will eventually be able to replace the content, but that is just our opinion. But for the time being, we saw that maybe this would be best as a supplementary teaching. And which kind of comes to the other conclusion that says that this test doesn't really close the case on VR, or in other words, it doesn't prove that VR is not a viable option. There just shows that there's tremendous room for improvement and growth, and the time invested into training is already huge before VR, and now it has to be invested into more of a VR approach. And we believe that it will probably and can be very, very successful. So those are our findings for our project for Engineering 450 at Liberty University. Thank you for watching.